This will be the last video of the night. We're going to look at how bacteria grows with this function. So we're going to use a logistic growth function. If you've never heard of this before, don't worry about it. This function is used to model population growth of any population you can think of. People, deer, in this case bacteria. And we're going to look and see how much bacteria we have at a few specific times. How much do we have at the beginning, after 1 hour, after 10 hours, and then what can we expect the upper limit to be? And as you can see from this function, it is evening out. We do end up with a vertical or a horizontal asymptote. So if I were to plug in, and I'm going to let, well, no, I'll go ahead and I'll plug in the numbers for you. At least on this first one. Plug in the numbers. If it'll let me. E to the, of course, 0.4 or negative 0.4 times 0 is 0. And anything to the 0 power is what? Sure hope you can answer that. So we get 1 plus 0.25. So this ends up being 1 gram. We can expect that we are starting with 1 gram worth of bacteria. You go ahead and plug in the numbers, just do the same thing I did here. You should end up with these values. Check my math though, because you know I'm not good at the multiplication and the algebra, the arithmetic. Alright, now for the last one, we want to take the limit as t is approaching infinity. So I am going to do this one for you. I'm going to plug in infinity, and what's infinity? Times a negative exponent. Let's think about that one for a second. Okay, so I've got negative 0.4 times infinity. So ultimately this piece right here is going to negative infinity. And anytime something goes to a negative infinity, it means that it's getting closer and closer to 0 on the scale. So you end up with this entire term, well, this entire term, going to 0. So we end up with 1.25 over 1 plus nothing. Reaches that horizontal asymptote, which brings us back up to expect that as time passes, we will not get more than 1.25 grams out of the situation. We'll do a little bit more with logistic equations later on down the road. They're used in several places, especially when I took a math and biology class. We use logistic equations quite often to model our population growths of our different systems. So this is the last video of the night, last video for the homework I gave last week. If you have any questions, let me know. If you have any questions specifically on any of your homework problems, let me know and I'll do a video to go with those. But I can only do them if you let me know you're having an issue. So I will see you all in class on Thursday when we will start inverse trig functions and their derivatives and integrals. So get ready for that, and please don't wait until the last minute to do your homework. We'll see you on Thursday.